In this problem, we are working with experimental and theoretical probability. Melissa rolled a number cube 1,000 times and got the following results. So the outcome rolled is 1 through 6, and here's the number of rolls. So fill in the table below, round your answers to the nearest thousandth. So question A, from Melissa's results, compute the experimental probability of rolling a 5. So in A, one way to estimate the likelihood of an event is to repeat the experiment many times. The experimental probability of the event is the number of times the event occurs divided by the total number of trials of the experiment. In our problem, we get the following. So to get experimental probability, we take the number of times 5 is rolled divided by the total number of rolls. So we can see 5 is rolled 174 times. So we get 174, and there was 1,000 times the dice was rolled. So 174 divided by 1,000 is 0.174. Question B, assuming that the cube is fair, compute the theoretical probability of rolling a 5. So assuming that the cube is fair means assuming that each of the 6 outcomes is equally likely, because there are 6 sides to a dice. We use this to compute the theoretical probability. We don't look at the data at all. So theoretical probability is number of waves of rolling a 5 and the number of possible outcomes. So you can only roll 1 5 out of the 6 sides. So 1 divided by 6 is about 0.167. Now let's look at C. Assuming that the cube is fair, choose the statement below that is true. So the smaller the number of rolls, the greater the likelihood that the experimental probability will be close to the theoretical probability. The experimental probability will never be very close to the theoretical probability, no matter the number of rolls. Or the larger the number of rolls, the greater the likelihood that the experimental probability will be close to the theoretical probability. In C, the experimental probability is affected by chance. In the first few trials of an experiment, the experimental probability may be very different from the theoretical probability. But as the number of trials increases, the experimental probability will tend to get closer to the theoretical probability. With a very large number of trials, the experimental and theoretical probabilities should be very close. Based on this, the following must be true. The larger the number of rolls, the greater the likelihood that the experimental probability will be close to the theoretical probability. So the third statement was true.